Hello, everyone. My name is Mike Kistler. I'm a product manager at Microsoft in the ASP.NET organization and the product manager for the C SDK for MCP. And today I'm going to tell you about the SDK and also what we've done recently to support the new version of the MCP spec. So just to start, the MCP C SDK is an SDK for MCP that Microsoft is maintaining. It's the official MCP C SDK, which means that it lives in the Model Context Protocol GitHub org in the repo called C SDK. It's currently version 030 preview 3. It's a preview because the MCP spec is still evolving, and it actually still includes some occasional breaking changes. Now, we try to minimize that in the C SDK, but they are still happening, so we're keeping the SDK in preview for now. This SDK is used by many Microsoft products that are supporting MCP servers today, so it's getting widespread use already. There was recently a new version of the MCP spec released in 2025-06-18, and it had a number of new features. All of these features are already supported in the C SDK. And these are elicitations. This is an opportunity for an MCP server, probably a tool call, to request additional information from the user in order to carry out the tool call. I'll show you more. I'll show you a demo of this in a minute. Another feature is something called structured output. With structured output, the server can declare what the output of a tool call will look like. And this is important for LLMs because prior to the 06-18 spec, the tool call just returned a string. And that string could have structured output in it, but the LLM would have to discover what that structure was. It would have to inspect the output string and figure out if that was JSON, and if so, try to deserialize it and all that kind of stuff. With structured output, the tool call can declare in advance, this is what my output will look like, and then it can pass that structure in JSON back to the LLM, so the LLM can easily parse it and understand what's there. Another feature that was added in the recent version of the spec is the ability for a tool to return resource links. Resources are an MCP capability that have been there since the beginning. They are basically static resources, static files, if you will, that the MCP server can return and can be either used by the host or provided to the LLM. But previously, you just listed resources, found out what they were, looked at the description, things like that, and then the host would have to decide which ones to use. Here, a tool can provide a resource link that maybe is related to what the tool call request was about. It could even dynamically create a resource and then provide that in the response to the tool call. So that could be a very bulky output, for example, that would be permanently residing in a resource now that the LLM could call on or the host could call on at a later time. Finally, one of the big improvements in the MCP spec, the latest MCP spec, is a new authentication protocol. This new authentication protocol is still based on OAuth, but it now separates the authentication server from the resource server, which is really sort of the modern way of doing OAuth, particularly in enterprises. There was a great talk on this yesterday. Den Delamarsky and some other folks gave you all kinds of information about this. So if you haven't seen that talk, go check that out. It's a great resource. Okay, so now I'm going to just jump into some demos. Oh, actually, before I do that, I just want to point to the changelog, which is over on the Model Context Protocol IO site. Under the specification, there's a changes tab, and you can come here and you can see all of the changes that were made. in this version of the spec, also in prior versions of the spec. There are more than what I highlighted on the previous slide, but the previous slide showed, I think, the key ones that people are really going to be interested in. Okay, so let's get to the demos. So the first thing that I want to show you is elicitation. And elicitation is, again, the ability for a tool call to ask for input from the user in order to carry out whatever the tool call is supposed to do. There's parts that have to happen on the server and also parts that have to happen on the client in order to make this whole elicitation thing work. So I'll show you, starting off with the server part. In a tool, the tool is going to, first of all, check if the client supports elicitation, okay? And if it doesn't, then it should do something appropriate. In my case, what I'm doing is I'm just saying, look, I'm not going to run, I'm going to fail because I can't carry out my function if the client doesn't support elicitation. The tool that I'm building here, by the way, is a simple tool called Guess the Number. And this is just an example that illustrates how you do elicitation. And I chose this because when you do elicitation, you can ask for input of a particular type, but only primitive types. So you can ask for Booleans, or you can ask for strings, or you can ask for numbers. And this particular tool gave me the opportunity to show all of those. So the next thing is, when you want to go make an elicitation request, you first have to say what the type is of the information that you want, and you're also going to describe what that information is. So here I'm saying I have a request schema for a Boolean. Okay, that's going to be the answer, and I'm going to ask with an elicit async request, do you want to play a game? So I'm saying this is the information that I want. The output that I want is a Boolean, okay? And then we send that to the client with this elicit async request. The client is going to prompt the user for that information, send back what the client said. The client might not answer or might decline to answer. And so that's indicated by this action field in the response. And what we're looking for here is that the client actually provided an input, which means that they accepted that elicitation request. So we look for the action being accept, and then we check the value. If the value wasn't true, the client didn't want to play, then we just end the tool call right there. Otherwise, we go on. The next thing that we do is we ask the client for the name of the player, or the user for the name of the player, and we send that elicitation request down to the client. Now, something I'll point out here is that in this schema, you can also send along validation attributes so that the client might be able to use those to check that the input was correct, or display, set up the input in a particular way. You can imagine that if this is a web client, they might structure their fields in a particular way so that you can only enter 50 characters, something of that nature. So we get back the name, we make sure that the client actually got an answer from the user. And then we're going to go into our little iteration here, where we're going to have a number that the tool picks and ask the client to guess that number. Here we're sending down a request for a number. We're saying it's a minimum and maximum, minimum of 1, maximum of 10. The user will get that. The client will respond with that answer. And here we're just going to check that answer. If they guess the right number, we'll say, great, you're done, and we'll end the tool call. Otherwise, we're going to respond and say, you're either too low or too high, and we'll do another iteration of the guess. So that's what the server code looks like. The client code is up here. And we start by when we initialize the request, the connection with the server, the client has to declare its capabilities. MCP is all about having capabilities that the client supports and declares to the server, and the server has capabilities that it declares to the client so that they don't get out of sync and try to do things that aren't supported. So here we have a capabilities that we're passing in the client info object. And the client declares that it can handle elicitation, and it does that by specifying a handler that is going to get called when these elicitation requests come down. And what that handler looks like is down here. And it's going to get an elicitation request. Here, the first thing I do is I look to see, are there properties that are being asked for? These are the actual inputs, because you can ask for more than one input at a time. So if there are no properties, then there's nothing to ask for, and we just return an empty result. Otherwise, we take the message that was provided that indicates this is the information that I'm looking for. We display that to the user, and then we go through each of the properties that are in this solicitation request and prompt the user for these. Now, what I'm showing here is a client that's just a simple console app. You can imagine that the client might be a web app or something that would dynamically create a form for this information. But I think this illustrates the idea of what the client should be doing, what the host should be doing with this information when it gets an elicitation request. Each of these properties indicates the schema. I showed you that earlier. So it's going to decide what type of information is being asked for. If it's a Boolean schema, it's going to read some information from the client, and then it's going to try to parse that as a Boolean. Now, the C# try parse for a Boolean only accepts true or false. So I added some special code here for yes or no, which would be a common way for someone to respond to that. If it's a number schema, we take the input from the user and we try to parse that as a double, and then we send that back to the server. And if it's a string, we just accept that string and serialize that as JSON and send it back. And once we've got all that done, we send the elicitation result back. And notice that we set the action here to accept, so that we make sure to tell the server that, yes, the user did provide all the input that was requested. So let me show you what this looks like when we run it. So I'm just going to run the server here, and then I'm going to start another terminal, and I'm going to go to the client. So the client's going to run, it's going to connect to the server, get that elicitation request back, and you can see that it's now asking the user, do you want to play a game? So we'll say, yes, we want to play the game. What's your name? I'll tell it my name. And then we guess a number. So let's guess 5. My guess is too high. So we'll try 3, too low. So it must be 4. There we go. So this was an example of a tool call that was needing additional information from the user and using elicitation to get that through the client from the user. All right, that's elicitation. Let me show you the next feature. The next feature I'll show is structured output. So let me, first of all, start by killing this server, because we're going to be starting a new server. All right. So structured output, as I mentioned, is a way for a tool to declare what its output is going to look like. And here we have a product tool that's going to return a list of products. And that list of products has a product class, and that's described in our models section. Here's our product models, and you can see that here's our product model that has an ID, that's the identifier, the name of the product, all these fields, right? And we would like to be able to tell the LLM that this is what the structure is of the information that we're returning. Now, the way that's done, it's very simple. All you do is you add a parameter onto the MCP server tool attribute when you declare your tool that says, I'm going to use structured content. Now, just adding that parameter will do two things. First of all, it will, when a tools list call is made, it will include an output schema that's a JSON schema that describes the output of this tool. okay, as declared here, this list of products. And then the second thing that it will do is when the tool is actually called, it will include not just the string representation, which is there because it was there before, and we're just continuing on with keeping that, but will include a structured output that is actually the JSON output of the tool call. So let me show you how that works. So we'll go to structured output, start this guy up. Now for this, I'm going to interact with it from a Polyglot notebook. And if you haven't seen Polyglot notebooks before, they're really awesome. You can, in this notebook, have C#, you can have PowerShell, you can have Python, all kinds of different code, and you can just sit in here and run that code to see the result. Here, I'm just going to issue a curl command, and I'm doing this rather than using the REST client because I want to actually massage the output so that we can really see what's coming back in the result of my request for tools list. So here I'm doing a tools list, and I'll execute that call. Yep, so I got the result. So here's my result, and it's saying, here's the list of tools that this server supports, okay? And it's a get products. You can see the input schema, and now you can see there's also an output schema, and that output schema has an array of items. I'm actually going to have to expand this out because it's a very long list. Get back to where we see that. The output schema has this JSON schema that says, I have an ID, and I have a name, and I have a description, product, price, category, all these fields that are in the product. Okay, so that's what the tools list result looks like. Let's actually see what the result of the tool call is. So down here, I have another curl command that's going to do a tools call on get products. Okay, and it's going to show us just the result of that call. We're going to run that, and here's the result. And as I said before, we always just returned a string output. We're still returning that string output. Here is that string output, and you can see that it's actually JSON in there, okay? But it's just all in a string. But the structured content actually provides that JSON output as a JSON field. And so this can be provided to the LLM. The LLM can actually parse this much more easily, right, and find just the information it needs. So that's structured output. The next thing I'll show you is resource links. Resource links, as I said, are a way to return a link to a resource, an MCP resource, from a tool call. So here we have tools, my resource tools, and this is an example of what I was saying earlier, where a tool can actually create a resource dynamically and then return a link to that resource for the LLM to be able to access or the host to be able to access. So my tool call here is just called make a resource. It goes and creates a resource for a random number, okay? And then it will return that resource link. And here's what that looks like. It's just the resource URI and the name of the resource. That's what the resource link looks like. And I'll show you what that looks like now. So we'll run this guy. And this we can just look at with the regular old REST client. So here I'm going to do a tool call, and I'm going to call make a resource. We'll send this request. And what you see over here is what the response looks like. Now, everything in MCP is communicated with something called JSON RPC. So this is a JSON RPC message response, and it's coming back. Here you can see that it decided to generate the resource numbered 3, and it sent that back in a resource link, and you see the URI and the name Okay. And so now what we're going to do, we're actually going to request that resource. So last time it was 4. This time it's 3. And this call is a JSON RPC request to do a resources read. And I'm going to pass that resource URI that I just put in here, that was passed back here. And now you can see that resource responded. It told me this is the contents of that resource. This is a plain text resource, et cetera, et cetera. Okay, so that's resource links. Now, got a few minutes, so let me come back over here to my slides, and I'll just talk a little bit about the last thing, which is the authentication protocol. So some things to know about the authentication protocol is that the new authentication protocol is only for servers that are using the streamable HTTP protocol. For standard I/O, there's still the old method of doing authentication where you put credentials in environment variables or in configuration that the MCP server can access. But when you're actually using streamable HTTP and you need to talk over HTTP, you want to do OAuth. So this leverages a number of important features of OAuth, in particular the protected resources metadata feature of OAuth, so that when you go to the server, the MCP server, without credentials, it will come back and it will say, you can't access me unless you have authenticated, and here are the parameters, here's the information about how to authenticate. And that actually points to an authentication server that will provide the tokens in order to authenticate. There's also resource indicators, and that's a way of including in the access token information about what resources are being accessed. And this is just an extra protection to make sure that there's no token spoofing going on when you're getting a token from that authentication server and then passing it back to the MCP server. And finally, there's a feature called dynamic client registration. Dynamic client registration is a way of, because your client doesn't know a priori where the authentication server is, it might not be registered with that authentication server. The authentication server might not know about that client. And so you need to register your client with that authentication server. And this is a way of doing it dynamically, putting it all together so that all sorts of fits together. Now, I'm saying all this because these are all capabilities that sort of fit together in the whole of this new authentication protocol, but some authentication providers might not actually support these today. So you're going to have to do some research and make sure you understand which of these features are available in your authentication provider and whether this is all going to fit and work together. Looks like I only have a couple of minutes left. I do have a quick demo. There's a demo of the new protocol in the C# SDK repo in a directory called Protected MCP Server. Okay, and this shows you how all of this is supposed to work, how it all comes together and works. And there's information in here about how to actually run it. It has a test OAuth server that actually implements all of the features that we just talked about. And so you can use this, you run that test OAuth server, you can authenticate with that OAuth server to a protected MCP server, and there's a client that you can run that will do all the right communication protocols in order to get the token and provide that to the MCP server. I don't think that we have time to do that, so I'm just going to pass it back to the hosts and say, I think that's going to be it for me.
Thank you so much, Mike. Wow, we're here, back, and we got your questions live on the board. So
all right,
we got some good questions for you. So we're pretty stoked about it. In general, first, John Galloway, of course, just telling you, go, Mike, go. Big fan, the Galloway, the Mike together. And also, you guys are also always on the ASP.NET Core community stand-up on the .NET YouTube, so make sure you go over there.
I like this one over here from Daniel. That's a great question. Oh, you
have to read it.
I gotcha.
Yeah.
So it says, thank you, Daniel. For elicitations, would the MCP server need an LLM behind it to do that?
No. The elicitations are going to the client, and the client is getting that information from the user. The LLM is really not. So the way that the server can interact with the LLM is through another feature called sampling. Okay, but elicitation really doesn't involve the LLM at all at this point.
Okay, gotcha.
So,
Perfect.
so the LLM never at any point elicits the elicitation, if you will.
That's right. So it is possible to write MCP tools that have LLMs like behind them. These would be more, you would say, agentic MCP tools. Okay, so you might have an MCP tool that has an LLM behind it that says, "Oh, I need this additional information," and you can imagine that would happen. But that's completely optional. I would call it sort of an advanced scenario, right? More often, it would just be something where the tool is asking for information because it's gotten to a branching point and it needs help from the user to know which direction to go.
Got it. That makes sense. Someone was asking about all the code repositories over here. This is Abe was asking about that. Were you just using stuff from a personal repo, or is it
So
the
I'm happy to share this code repo. I've basically been building out a bunch of little examples of how you do things with the C# MCP SDK, and I can share that in the chat afterwards. Yep, happy to do that.
Sounds good. And we'll put links on the on-demand video, which a lot of people have been asking about as well, which they're right here on the Microsoft Developer YouTube. So same place you're watching it on YouTube is there. Good question here.
Yeah, that's a great one. Mike, is this the same SDK that's used by Visual Studio and VS Code?
Yeah, or other things at Microsoft.
So Visual Studio is using it, but VS Code, because VS Code is written in mostly TypeScript, is using the TypeScript SDK. But I mean, the beauty of MCP is that these are all supposed to be interoperable, right? So VS Code using the TypeScript SDK can talk to a server that's written in the C# SDK, because they're all just talking this common protocol. It should all just work.
That's perfect. I think the Azure MCP server is written with it, and several others as well.
The Azure MCP server is written in C#. Yep, it is.
Yeah, and I think all of them are also open source, the servers that we put out. And I think on the Microsoft for Developers blog, I'm sure John will drop a link on there. He has like 10 MCP servers from Microsoft to check out, and they're like all open source.